this video is going to walk you through some ideas on how to use the activity, the mathematics of ocean creatures, which is really focused on discovering patterns in nature, specifically ocean patterns. So we've got, if we scroll through this activity, you'll see there's some sand dollars and starfish and shells and even a dolphin. And we're just talking about how nature has patterns in it and can they work with the geometry and angles and points and things like that and try to discover some of the patterns. We've given them a hint that in nature the Fibonacci sequence, which we list here, you'll see at the top, appears, and so can they find that within the creatures that we've added here. And then we talk a little bit about the golden ratio and how if you do the ratio of consecutive numbers in the Fibonacci sequence, that you approximate the golden ratio, and as you go more into the sequence with the larger numbers, it gets closer and closer to the actual golden ratio. So can you find that type of pattern in the sea creatures? So the first thing we ask them to do is kind of explore, can you come up with the recursive pattern for the Fibonacci sequence? Can you create that sequence? So we're going to look at this. We kind of want to seed it with our first two, so the 0 and the 1, and then get that the Fibonacci sequence is, 0 plus 1 makes this third term. 1 plus 1 makes this 2, the fourth term. 1 plus 2 makes this 3. So it's adding the one before to the one after to get that next one. So we're going to, how do you write that recursive sequence? So this is the recursion sticky. So just a reminder, that's this A sub n. We've already got this out for students, and we have to make sure we have the right template. So we're going to go into the settings, and you'll see you can do a recursive or explicit sequence, but we're staying with recursive, and it defaults to this first one, but we actually have 2 seed values, and that's right here, so we're going to choose this one. So notice it then changes my template. It also brings up the soft keyboard, and if we go into math, there's a third tab that connects to our sequences so that I can get those A sub n plus 1. So let's talk about the pattern. The pattern is whatever term you're on plus the 1 after it. So we're going to, let's just use our soft keyboard here, do n plus 1, and we're going to seed it with our first 2 terms, so 0 and 1. And once I'm done, I can hit execute or enter, and it's going to create the table. Now, the default of the table is to only have the first 4 terms, but notice that they do match our sequence. So far it looks like we're doing pretty good. So we've got 0, 1, 1, 2, 3. So let's add to our table. And so to do that, you go to the table settings and notice it has a range which only goes to 4. It doesn't make any sense for us to go less than 0 because we don't have any negative in our sequence. But let's add a couple more terms. Let's go up to 15 terms. So all that is how many numbers do you want to see in your pattern. So this is the first 15 terms in our pattern. So notice that the numbers get very, very large as we continue to use this Fibonacci sequence pattern. So then it's asked them, it told them up above that as you get into the larger and larger numbers in the Fibonacci sequence, if you do their ratio, that you're getting closer and closer to the golden ratio. So we know we've already kind of explored this. Let's start with some of these numbers so they can pull out a calculator now and actually see if that's actually true. So let's just take 2 consecutive. So let's do 55 and 34. So we're going to do 55 divided by 34, and if we are following what it says, it should be kind of close to 1.6. So notice that it is very close. In fact, if we round it would be exactly the golden ratio. So let's pick another one. Let's pick the 14th and 13th. So 377 divided by 233. So these are larger, so it should be even more exact, which it is, just a little bit more exact. So what we are finding is that this pattern is true and the golden ratio exists. And so now let's then take these understandings, and there's a place for them to write down things that they discover. But let's go in and just talk about how could they use Classpad.net and all of these are in the geometry sticky, which if I click on it, you'll see it's the geometry tools. I have all my different tools that I can use here, and it says, are there any patterns? Can you find a Fibonacci sequence? And one of the things in a sand dollar is that it has every sand dollar, and these are 2 different sand dollars found coincidentally at the same time on the beach. And if you can see, it's a little hard to see, I know, but there are 5 points on my sand dollar, and this is where they can take their geometry and they can actually mark on the image. So here's 1 point, 2 point. I'm just going to the tip of the sand dollar's point here. So I have 5 points on this one. And if I go over to this one, which is slightly smaller, I'm having a little hard time seeing it, to be perfectly honest. But I also have 5 points. And then they could do things like, you know, where's the center of the starfish? And can I make a circle that connect, oops, I need my circle tool. So can I make a circle that connects those 5? And it looks like they do connect, so that's interesting. So they could just explore a lot of different things. You know, what's the angle if I measure these central angles to the points? Are they all the same? And what are those patterns, right? So 5 points, 5 angles, that's a Fibonacci number. What's the distance between the angles? What if I measured the distance across? Would I get, you know, any of the numbers in my sequence? So I'm not going to go through all the things that they could explore. That's up to them, what's of interest to them. But they could come up here and notice some different things. The golden ratio has to do with, you know, distances and values. So what values could they assign, and then see if there is a golden ratio connection. And so that's just some things to do with sand dollars. Same thing here if we look at the starfish. Now the starfish, we actually gave them some interesting information. It says if you measure the distance between the tips of the starfish arms compared to the distance from tip to tip across the entire body, it should be the golden ratio. So let's actually do that. Let's get a segment and let's measure the distance between one set of tips. And so to measure, I just used my segment tool and I'm going to measure. So I selected the segment, measure the distance. So that distance is 5.64. And then it says the distance from tip to tip across the entire body. So I guess we have to interpret that a different way, but maybe that means from here to here. So let's measure that distance. And so we might have to play around and figure out which distance are they, how are they really defining what tip to tip means. I mean, is it from here to here, or are they all the same? So that would be an interesting investigation. But let's measure that distance too. So we've got 9.992, and it's saying that these ratio of these should be almost the golden ratio. So let's actually check. Let's do 9.92 divided by 5.64. Execute. And it's a little bigger, but it is pretty close. And so that could be, maybe I'm not precise in my measurement here. It looks like C is not quite on the tip. So really interesting things they can explore that are kind of, you know, is this distance the same distance between these? Like, and that's really interesting in nature. And that's a 5. So is this also a 5 point something, 5 point something? There's 5 tips. That's a Fibonacci. Lots and lots of things they can explore. So that was just a couple from that one. When we get down to the shell, the thing they're given is that there's also a golden ratio in here as well. And it's if you measure the distance of the growth. So the growth of this shell starts at this center point here and goes out. That's its first, kind of like think of a ring of trees. So a distance here, and then the distance from there to this one, and then there to this one should be in the golden ratio. So let's just, you know, again, let's attempt to do that. Let's get a segment here and try to measure. And this is going to be hard because it's really small. In fact, it doesn't even want to go that small. So maybe what we could do is zoom in a little bit and make it a little bigger. So all I did was use my zoom so I could make that shell a little bigger. And so now I'm going to go from the center to here, to the edge of this. That's one distance. And then let's measure that let's measure that distance. Okay. And then let's move this out of the way so that it's off to the side. Now let's change our color so that we have a slightly different one. So now let's get our segment and let's make this one dotted. And let's go from this point out to, oops, I gotta have a segment. This point out to the second ring, right? And let's measure that distance. And let's see if we do get the golden ratio. So again, we're going to just get our calculator out and divide. So 0.62 divided by 0.25. It's a little bit, so maybe that's not what they mean. So we need to explore, but maybe it's this next one, or maybe it's the distance here to the distance here. So let's undo that last segment that we did, and maybe we need to measure this distance to here, and maybe that's the golden ratio. Let's see. So interesting things that they can, explore and discover. That's 36. Oh, that does make a little more sense. So let's see if that's a better one. So 0.36 divided by 0.25. I think that's going to definitely be a little bit closer. So a little closer, absolutely. So kind of figuring out what they meant by that. So it's really this distance, this next distance, this next distance. So not always starting at the center is which I was doing. So again, different things they can explore. What are the interesting patterns? And isn't that amazing that nature has them? And so then the same thing down here with this dolphin. There's kind of an image that shows them some golden ratios. So like if you measure the width of the dorsal fin and then the height and you compare them, you're going to get the golden ratio. That's why dolphins are so pleasing to look at. So same thing here. If you measure the distance here compared to the distance from here to the eye, it's going to be the golden ratio. There's lots and lots of different golden ratio measurements here in a dolphin. And so then, here's a real dolphin. Does that seem to exist? So we could, again, get our segment tool, and let's try to find the distance at the base of this dorsal fin. So there's one distance. I probably should change this color. And then, so that's one distance. And now let's change the color so that it stands out a little bit more on our blue here. But let's now measure the height of that dorsal fin. So from here to there. Probably need to make it a little straighter. There we go. And let's measure that. And now let's get our calculator tool out and see if we're kind of close to the golden ratio. So 0.67 divided by 0.40. So lots of interesting things they can do, and then we can just check, and it's pretty close, right? In fact, very close. So really interesting, fun things, and just realizing that nature isn't random. It seems to have a pattern in it, and even the same type of shells have the same type of patterns, and so that's really interesting and exciting. So have fun with this, and let your students just explore and come up with lots of different things. Don't really necessarily direct them, maybe give them some hints or something, but let them figure out some patterns that they find interesting.